So, Sridhar students, let's discuss units of forces. The dimensions for force is mass into acceleration, so mlt minus 2. The units of forces are two units. The first kind of unit is known as absolute units. The second kind of units is known as gravitational units. Gravitational units are practical units. In calculations, you will convert these units to absolute units first before using them. What are the absolute units? Two types of units in absolute units. One belong to SI system. Second belongs to the previously used measurement system known as Cgs system. In SI system, mass is in kilogram, length is in meter, time in seconds. Here, the mass is in grams, the length is in centimeter, time is in second. Absolute units of force is Newton. How do we define Newton? We have learned from second law of motion, F is mass times acceleration. Now, let's take, so that is F is equal to M into A. All right. So, if I take mass as 1 kg, that is a basic unit in SI system. And if I take acceleration also unity, acceleration is meter per second square. If I take acceleration 1 meter per second square, and if I take mass as 1 kg, I will get force as 1 Newton. How do we define it? Define it as like, suppose there is a body of this mass, that is 1 kg. If I apply this much force on this body, it will be accelerated by this much amount, that is 1 meter per second square. In other words, I can say if the acceleration caused, if acceleration caused in a body of mass 1 kg by the application of some force, that force is said to be 1 Newton, or 1 Newton force always causes an acceleration of 1 meter per second square when applied on a mass of, yes students, when applied on a mass of 1, come on, anyone? 1 Newton force causes an acceleration of 1 meter per second square when applied on a mass of 1 kg. So that's all about the SI system of force. All right, CGS system here. Again, F is equal to M times A. In CGS system, yes Ishma, the mass is taken in CGS system.
Dine.
No, wrong. In CGS system, the mass is, I'm asking about mass. The mass is taken as in
Gram.
gram into what will be the unit of acceleration in CGS system? What will be the unit of acceleration in CGS system?
Centimeter per second square.
1 centimeter per second square. If I take acceleration to be unity, 1 centimeter per second square. If I take mass to be unity, that is 1 gram, the force applied is said to be, here you should say 1 dyne. So, how do I define dyne? 1 dyne is defined in a way, suppose I'm having gram mass, 1 gram mass is pushed by some force. That force is said to be 1 dyne if, yes Ishma, can you complete? That force applied on 1 gram mass is said to be 1 dyne if it causes an acceleration of
1 centimeter per second square.
per second square. Done. Now, interconnection of Newton and time. 1 Newton is equal to 1 kilogram meter per second square. Let's convert kilogram into gram, 10 raised to power 3 gram. Let's convert meter into centimeter, 10 raised to power 2 centimeter per second square. Now this will be equal to 10 raised to power 5 gram centimeter per second square. This is equal to 10 raised to power 5 dyne. That's all. So 1 Newton is equal to 10 raised to power 5 dyne. Please note that. Students, gravitational units of force. Again, system we have is SI system. On the other hand, we will have what? We will have CGS system. All right, this defined already. Now, in SI system, gravitational unit. Okay, now again, you see that students F is equal to ma. Here also I'll say F is equal to ma. Now, students, the CGS, the SI system of SI system defines force, its gravitational unit as 1 kilogram weight. Okay, you need not write one, I'm sorry, kilogram weight. Kilogram weight, or this is also known as kilogram force. Once again, gravitational unit of force in SI system is kilogram weight or kilogram force. Now 1 kilogram weight definition. A force is said to be 1 kilogram weight or 1 kilogram force if it is applied on a mass of 1 kg, if it gives an acceleration equal to g, acceleration due to gravity. How much is that? 9.81 meter per second square. All right. Now, how do I define 1 kilogram weight or 1 kilogram force? This much force is said to have been applied on a body of 1 kilogram, produces an acceleration of, yes Ishma, if 1 kilogram weight or 1 kilogram force is applied on mass of 1 kilogram, will produce an acceleration of, come on,
9.81 meter per second square.
81 meter per second scales. Here in CGS system, the unit is said to be 1, yes, 1 gram weight or 1 gram force. Again, I'm sorry, the unit is not 1 gram weight. The unit is gram weight or gram force. I was just excited to define 1 gram weight or 1 gram force. Well, 1 gram weight or 1 gram force is said to be applicable on a body of mass. How much, Ishma?
1 gram.
Weight or 1 gram force is said to have been applied on a body which is having a mass of 1 gram when it is accelerated by, come on, when it is
981 centimeter per second square.
beautiful, 981 centimeter per second square. So 1 gram weight or 1 gram force is equal to 1 gram into 981 centimeter per centimeter square. Well, this is equal to 981 gram centimeter per second square. Students, this gram centimeter per second square is actually the definition of dyne. See here, one dyne is 1 gram. See here, gram centimeter per second square. So on the basis of this, I can say that what? That 1 gram weight or 1 gram force is equal to 981 dyne. All right. Similarly, coming back here, 1 kilogram weight or 1 kilogram force is equal to, see here, this is 9.81 kilogram here meter per second square. But kilogram meter per second square is what? Kilogram meter per second square already defined is 1 Newton. All right. So I get 1 kilogram weight or kilogram force is equal to 9.81 Newton. Remember that if it is given the force acting is 70 kilogram force. Suppose Ishma, force acting is 70 kilogram force is given, then it will be equal to how much Newton? Come on. If it is given in a numerical force is 70 kilogram force. So this will be equal to how much Newton? 1 kilogram force or 1 kilogram weight is equal to 9.81 Newton. So 70 kilogram force will be equal to, come on, 70 kilogram force would be equal to, guess, 70 into 9.81 Newton. Remember that. If I roughly take it as 10, it will be approximately 700 Newton. All right. Oh, that's great. Okay. So, one more question. Let's say, you know, let's say the force is one, let's say force is 10 Ishma, let's say the force is 10 gram weight. So how much will be the force in dyne? Can you tell me? If the force is 10 gram weight, how much force in dyne? Force is equal to 10 gram weight. So it will be equal to 10 into 1 gram weight is equal to 981 dyne. 10 kilogram weight will be equal to 9810 dyne. Remember that. So guys, this is the two prominent units of conversion. I would request you to subscribe our channel Learn CBSE if you haven't subscribed yet, and listen to some creative videos. Thank you.